Hi everyone. In this video, I'm going to solve another question from operating system topic, and the focus is on round robin uh, scheduling algorithm. Round robin is a preemptive scheduling algorithm because it's got a time slice or the time quantum, which in this question 3 milliseconds. As you see here, we've got four processes with different arrival times and different burst time. And what we need to do, we need to draw the Gantt chart. If you want to draw the Gantt chart for round robin, don't forget the first thing you need to draw is the ready queue. So technically we need to create two charts here. One of them is ready queue and the other one is round robin. So let's start, but again, what is very important to know the arrival time of different processes: millisecond 0, millisecond 2, millisecond 4. So at millisecond 0, P1 arrives, millisecond 2, P2 arrives, and in millisecond, at millisecond 4, P3 and P4 arrive. Let's start and create a ready queue and the Gantt chart simultaneously. Okay, this is my ready queue and this is my Gantt chart. Okay, again, because this is preemptive, it means that at every 3 milliseconds we can look at the ready queue and choose the process. What I do, I show the process arrival and the process on the Gantt chart. It helps me to understand what I need to do. So at millisecond 0, at millisecond 2, and at millisecond 4. So here I have P2 and P4 and P3 arrive at this millisecond 4, I mean. Okay, let's start. So we are at millisecond 0 and the only process that we have is P1. So P1 gets CPU time and P1 goes to the ready queue technically. As the time slice is 3 milliseconds, it means that no one can use more than 3 milliseconds. It means that P1 should stop at second 3. While P1 was actually was on the CPU to be implemented, P2 arrives. It means that before we finish the third millisecond, P2 arrives. It means that immediately P2 goes to the ready queue. P1 uses 3 milliseconds. Don't forget that you need to take away that 3 milliseconds from the burst time, and P1 at the moment has got 4 milliseconds remaining. But because it has some remaining, look, we are at milliseconds 3. P3 and P4 are not there. We have only P1 and P2. P2 goes to the end of the queue. But because P1 has got remaining, it goes back to the ready queue. It means that as soon as P2 finishes, we need to give the CPU to P1. So P1 got its CPU time. It's time for P2. P2 gets CPU time. It goes from millisecond 3 till millisecond 6, again because the time slice is 3 milliseconds. First of all, at second 4, P3 and P4 arrives. It means that immediately they go to the end of the ready queue. And what happens, 3 milliseconds actually goes and the burst time of the millisecond becomes 0 because nothing arrives. So finish, we don't have anything to do with P2. P2 actually done. Now the next one based on the ready queue is P1. P1 again gets CPU time. It goes for another 3 milliseconds, 9. Don't forget, you need to take away 3 milliseconds and 1 millisecond remains. But again, don't forget, because P1 hasn't finished yet for the remaining burst time, it goes back to the end of the queue. So P1 goes back there. So we use that P1. The next one is P3. P3 gets CPU time. P3, 5 milliseconds remains. Again, P3 goes back to the end of the queue because it's got remaining. P3 gone. The next one is, don't forget, 9 plus 3 is 12. The next process is P4. It's only 2 milliseconds. Doesn't matter. It's less than the timer slice. Less than 3 milliseconds. But this is what it is. So P4 gets 2 milliseconds only at this time, and finish, nothing remains there. The next one goes back to the ready queue is P1. P1 needs only 1 millisecond, so that's fine. P1 gets CPU time 1 millisecond, it's 15. And for the rest, what we have finished, only P3 remains. P3 is 5 milliseconds. You can show that in actually 2 slices. First of all, for example, for the first time slice of that 3 milliseconds, it becomes 18, and again 2 milliseconds remain from that. P3 again goes back to the end of the queue, which is 2 milliseconds for that, and it leaves at second 20 millisecond 20. Now what we need to do, we need to construct the Gantt chart based on the numbers that we have. In this specific number question, I need to just put the numbers, so it becomes 1 2 1 3 4 1 3 3. This is how we solve this question. Don't forget, for the round robin, it is important to know how to create the ready queue and the Gantt chart. I hope I could explain well the preemptive round robin scheduling algorithm. Thank you.